Okay, welcome back, guys. Today's topic is going to be something that is quite important because you're going to have to use some of these for the rest of your assignments. Okay, so please try to pay attention. The topic we're going to cover today is about sorting, filtering, and indexing. Now, these are very important topics in database because you will use your database for these things. You'll be wondering, right now you have only been storing, say, a single player information, or maybe just 2 or 3 players. But in reality, the reason why you use a database is because you have a lot of data to deal with. You may have hundreds, if not thousands, or even millions of players. And if you have to pull out a bunch of players, you need a way to find those information in your database. And that's why I use a database. Otherwise, why put it in a database, right? If I had only one player's config, I could just store it in the file, right? So that's the whole point of database, is that you have structured data, a large amount of them, and you have to sort through it, filter it to pull out the information you want. And then, of course, to improve your sorting and filtering performance, you need something called indexing. And so that's the 3 topics we're going to cover today. Now, for the purposes of the lesson today, we're going to use a new set of data. I'm going to hopefully try to upload this data somewhere. It's quite big. It's about 50 megabytes. You may think it's not a lot, but actually it's quite a lot of data in here, okay? There's about, I think, 250 countries and about 177,000 cities in this JSON file alone here, okay? It's huge. So I'm not going to go through it, but basically we have a bunch of countries and a bunch of cities. And I think you all know what countries are. There's country name, country has an emoji, a flag, maybe it has an alpha 2 code. This is what we're familiar with, SG, okay? And there's a dialing code for our phone numbers. There's also the alpha 3 code. And there's things like, what's the name of the capital, the lat long, the position, and the time zones. Why is an array? Some countries have multiple time zones in there. And then a bunch of cities. Right, Singapore, oddly, is one of the few countries in the world that only has one city in the country. Or maybe the country itself is a city-state. I don't know how many there is, actually. I haven't done that research, but anyway, it's quite a unique combination. But most countries in the world have multiple cities. Like here, we have Shanghai, which is a city in China. So there's stuff here, and this interesting number here called the population. And we'll do something with the population maybe in one of the demos later. Okay? And so for the purposes of this demo, we're going to start with sorting. Now, what sorting? I think we all know what sorting is. Basically, if I have a list of things A to Z, I want to sort them in order, right? Or I have things that are numeric, say from 1 to 10, I want to sort them in order, 1 to 10. And so most of the time, we sort things in ascending order, and that's how your Firebase will do it. Now, some of the things that we teach today will definitely have the same concept in other types of databases, like SQL databases, which are more popular. But the techniques for that we're going to learn today are specific to Firebase. And so they are quite unique. They work a little different from your SQL databases, but the concepts are the same. You just need to know that there's sorting, filtering, and indexing. Now let's talk about sorting first. There are 3 types of sort operations you could do in Firebase, and they are called OrderByChild, OrderByKey, and OrderByValue. Let's start with OrderByChild. OrderByChild means that you're going to sort something by using the value of its child. Now, in this example, if I have countries, right, I want to sort it by the child value, alpha 2. It means that I want to sort all the countries by its alpha 2 value. And in this case, it will then sort them by alphabetical order, in ascending alphabetical order, A on top, Z below. Malaysia, for example, will be above Singapore, okay? So, if I wanted to sort by the dial code, you could. So let's say USA, which has the dial code of 1, would be all the way on top. Okay, so we're going to do this as a demo. Now, the other one is OrderByKey. OrderByKey, you basically are trying to sort it by the key of its child. So in this example, which is the way the current data set that I'm going to use is designed, all right? Countries is an array, and in that array, there's a bunch of objects. This is the current data set that I'm loading and using, okay? Every country, let me just scroll up, every country here is an object. One object, you know, two object. There's no key, okay? This is an array. Now, if, and this is an example, right? If your countries was designed like this is more similar to how some of you design your players table, where you have the player ID as the key and then the object under the player ID. Now, if you had it designed this way, then you would use something like order by key. Order by key means you're trying to order it by the key of its child. So countries, and you have keys, and it would then sort by the value of the key here. Sorry, not the value, the key itself, right? The key itself. So Malaysia, for example, if you ordered by key, will be above Singapore in this case, right? M comes before S. And this is how you use order by key. And the last one is order by value. Now, order by value is a little different. So assuming you had something like a leaderboard, and in here are just simple key value pairs, where the value is not an object, okay? The value is just a simple value. So Steve has a number, Alex number, Kai number. These are presumably the scores. Now, if you use order by value, then it would order by the value of its child items. So for example, in this scenario here, it would actually sort the leaderboard with Alex being the first, ascending order, remember, then Steve, then Kai, okay? So the smaller number on top, the bigger number at the bottom. So if you had a data structure like this, you would then use order by value. Okay, so before I go on to my demo, while I'm doing my demo, or you can pause the video, give this a thought. Now, leaderboards are usually high score on top, low score, the lower scores are below, right? So if you use order by value here, you actually get the low score on top and the higher score below. How would you reverse this order? I'll let you think about it, and I will tell you the answer at the end of this section. Okay, so let's do a demo. I have my Unity open. I've actually turned off my canvas here. This is the previous sign up, sign in UI thing. I turn it off to reduce distraction. Make this window here bigger because we're just gonna look at data that comes out. I'm not gonna do anything on the game scene at all. Okay, and I have my database controller and the script's still there. I'm just gonna open that script right now. I have an empty database controller. I've kind of pushed all my old code down. I don't want it. They're not going to be run, so ignore the old code. Let's start on an empty plate and let's talk about sorting. Now, first, this should be muscle memory by now. We just want the database root reference, right? So let's just do this var db equals to Firebase database. Of course, remember to import Firebase database here. Firebase database dot default instance dot root reference. And you have the database root reference here, and now I can use the root reference to get the child. Okay, and let's just say I just want a bunch of countries, okay, and I'm just gonna get value async. This is me retrieving my countries. We have learned this in previous videos, and what we're gonna do is we have a var retrieve task. This one, okay, I would say countries retrieve task. Okay, let's give us a slightly more meaningful name. And remember, this is a task, it's an async function. So I'm gonna say continue with on main thread and task. I'm just gonna do the task asynchronously. So all the stuff in this yellow brackets will be running asynchronously. And I'm gonna do some stuff here. Now, you would typically do some error checking just like what you did for all your, create, update, whatever. You're gonna say if task.is faulted or task.is cancelled, and then you're gonna do something here, debug.log error loading countries. Okay, and remember to return. What does this return do? It gets out of the method, and the method is actually here. You're trying to get out these yellow brackets. You get out. Okay, so if there's an error, get out. If task.result is empty, exists. Okay, so if it is empty, means it does not exist like this. You're gonna say debug.log no data found in for countries. Okay, there's another error checking, and you're gonna return and get out. So these two are just checking for data. The last one is, now I've just retrieved a bunch of countries. Remember, my countries is an array. And so I'm just gonna have a bunch of arrays that come back. And how do I read the array? Now, one way is I can create a data object. I can do this. I can say public class countries. And of course, I will not do this in this file. I'll do it in another file, but I'm just doing it here just to cut short my demo time. Okay, so I create a countries class like this. And then I would say public list of countries like this. And then I will create a public class country, right? And I'll put stuff like, public string name, okay? And this, I would have a countries list, right? That contains a bunch of countries that has name. Now, if I don't want to create this class, it seems a little bit redundant, okay? It just only has one thing. I don't want to create it. It's kind of a waste. I could only just create my country data class and loop through the countries in my code here to load the country one by one. Okay, how I'm gonna do that? So let's just look at country first. In countries, I have name, alpha 2, alpha 3, and dial code. So I'm just gonna recreate this in my data structure. I'm just gonna put some information in here. Some things don't have to be populated. Okay, that's absolutely fine. So I have a country class, and by right, once again, I'm just put a comment here. This should be in a separate file, country.cs. Now don't give this to me. Please make sure you put each class in a file. Okay, I'm just doing this for the sake of the demo. Now, how do I loop through the countries that I just retrieved from my my retrieve task? This is how I do it. For each, okay, task.result.children. Now, if I hover over children, it's a enumerable. That means that it's kind of like an array. Okay. We'll talk about enumerable maybe sometime in the future, but it functions like an array. So you would say it's something they can loop through. Okay, so it's var country in. So basically, you say for every item in children, I'm gonna set it to the country variable. So you can use the country variable in your loop, and it will be going through the countries one by one, 1, 2, 3, 4, 5. So what I'm going to do is now for debug log, for the purposes of the demo, I'm just going to say country. And what is country actually? Let's just, before I type anything, hover over this and it says data snapshot. Now, if I hover over result is actually a data snapshot as well. So basically, every data item from Firebase is a data snapshot. And you have the same methods from the data snapshot, that you got, with your retrieve and all that. It's also a data snapshot, right? So task result is a data snapshot, and you hit dot, you get the same stuff like get value, get raw JSON value, right? And so if I just wanted the value, here I'm just gonna get a raw JSON value and just print it out, okay? And on top of this, I'm gonna do the deserialize stuff later, but let me just print the JSON out, okay? And for the fun of it, I'm just gonna do this. I'm just gonna debug.log, and I just say loading countries, ... okay? At the start, and I'm gonna say here, finished loading count number of countries. I'm just gonna put an integer int count equal to 0, and every time I loop, I'm just gonna increment my count, right? And I'm gonna print the count out. I'm just gonna say how many countries I loaded. Okay, that's it. Let's do the demo. Let's run the code now. Done. Okay, I'm just gonna stop it first. Now, it's finished loading 251 countries. Look at the time, 23:28:07. I'm just gonna scroll up all the way to the beginning. and 23, 28, 06 loading countries. So it took 1 second to load the 250 countries. And for the fun of it, let's just look at the list here. It's go like A. It seems like it's sorted, but all of a sudden it goes to I, and then J, and then K. So it's clearly not very sorted. Okay, AU, Australia is somewhere in between. So that's not great. So let's just fix this first. Instead of just printing the JSON, let's just do the deserialization. So var C equals to JSON utility from JSON. I'm going to convert it to a country object. So I say country dot get raw JSON value. Okay. And then I have the country. So maybe I'll just call this data. Okay. Data. Okay. And now I actually have a country. So this is just data, right? I get the raw JSON value of the data and I get a country from it. And then I'm just going to print the country out. So debug.log and I say country.alpha2 and country.name. Okay. And this would print, SG Singapore, right? It'll print it up. And let's just run it, make sure my deserialization thing works. Hopefully it didn't blow up. Let's try it. There you go. We have HU Hungary, HK Hong Kong, and it's clearly not sorted because there's definitely a Vietnam in here. There you go, Vietnam. It's kind of in the middle. So it's not sorted. Now let's fix it. Let's sort it now, okay? So how do you sort it? All you have to do is go up here in your retrieve task, right? Child countries, and you just say sort, order by child. Why child? Because once again, this is my data structure. I want to order by, say, the alpha2 code of the country. And so I want the countries to be ordered by the child value of alpha2. So I'm going to say order by child alpha2. So I'm just going to run it, and let's see now the list should be sorted. Bingo! Now we have Zimbabwe. I think we all might know this. This is a country that has appeared in our geography textbooks for a while. Zimbabwe. So that's the last one. And if you scroll up to the front, you have all the A countries starting here, and Australia definitely should be up here, right? Because it was in the middle just now. So Australia, B, C, D, E, F, G, H, I, J, K, L, N, O, P, Q, R, S. Singapore should be here. There you go. And you get the idea. Okay, now I've sorted it. And of course, you look at this, it's still very quick. It started loading at 23:31:01, and it was done like within the same second. So it's very fast. It's like within 1 second, everything is loaded. Okay, we have done that. Now let's just try another thing. If I wanted to sort it by something else, say the DAO code, I could. All I have to do is change my child to DAO code. And if I went back to my Unity and I ran it, first one should be United States because there's one. Okay, so look here, first one, maybe it's not. I don't know what the DAO code is. I should have printed it out, but you can see the sorting is very different now. Okay, for the fun of it, maybe we print the DAO code up. Country.DAO code, country name. Okay, maybe put a plus here, just to make it look fancier. Let's run it. There you go. Let's scroll up. Oh, there's no DAO code. These countries have no DAO code. So see, United States, Canada, +1. I don't know what. There's a space in the data. It's kind of like a maybe this is +1, +1, 3, 5, 3, 4, 5. Anyway, here you can see DAO code. So these are all using the +1 DAO code. There's a space in between, and that's the reason why DAO code is a string, not a number. Okay. Anyhow, if you scroll down enough to +6, you would find, sure enough, Singapore. Okay. So we have now sorted it by DAO code. Now let's just fix that. I'll change it to alpha2. Now I kind of explained sorting by child, and unfortunately the data that I have doesn't allow me to use the other sort methods. Okay, and as a practice, I would like you to go and find out what sorting method you could use for your data. So if you had a players list, for example, that had a key before the object, then you can go try order by key and see how that works. Okay, and if you were trying to do a leaderboard and your data looks like this, then go ahead and sort it with order by value. So that's for sorting, and I think sorting is quite easy to understand for most people. Now, to answer the last question here, how would you reverse it? Unfortunately, in Firebase, there isn't an easy way to reverse sort something, okay? And so what usually we will do is we will load the data in its ascending order and reverse it in code. And there are array methods to reverse it. So if you had an array, let's just say I have an array int of scores, okay? Name it, let's say I have 5 scores, okay? And scores are like 1, 3, 4, okay? I have a bunch of scores, okay? And it will be sorted. I could reverse it like this, okay? So if you had an array, you could reverse the scores. Okay, it's an enumerable, so I can change it. Okay, I could reverse the scores this way, and then I could print it, right? I could say for each in score in reverse scores, okay, and I'll print the scores out. Or I will put it in my UI, however you want to design your game. Usually in your game, you would put a few text fields and you text, things, and you put the scores in them. So you could do that. Okay, you can reverse the scores. But if let's say you're making 5 scores, you could just like set them in reverse order if you want. Okay, so there are different ways to reverse the scores. But if you want to programmatically reverse it, you can use the reverse method. And of course, the other way is to actually write your own algorithm, reverse it, but that's not a topic for this module. Okay, so I've talked about reversing. Back to the rest of the module. Filtering. So what's filtering? Filtering is basically picking out data that you want. So if I say I only want people who are having a score of bigger than 1,000, I would then add a filter to filter people with that condition, okay? And so the way it works here in Firebase is a little bit wonky, I would say. This is the unique way that Firebase operates. To filter, you have to first sort. Why sort? Because by using sort, you pick out the key which you want to filter. So as an example here, if I wanted to filter the country, pick out the country that starts at Hong Kong and ends at SG. These are values, okay? Let's look at this. These are values that belong to the alpha 2 key in countries, right? This country object has a key alpha 2 with the value AF, okay? And so I'm picking the key, I'm picking the key, and I'm getting the value and using that to filter the value. So if I did this, let's just copy exactly this code here, okay? And now it's getting too long. How do I make it readable? I just hit enter like this, okay? Okay. Now when I do this, it's much easier to read. So I'm getting countries, okay, and sorting it by the alpha 2 in ascending order. And after I've sorted it, I want it to only list things that starts at Hong Kong and ends at Singapore. So it's going to pick out stuff from H to S, somewhere in between, and print out all the list of countries somewhere in between, right? Anything that's, before H and after S should not be printed. Now let's try it. I haven't tested it, but let's see. Sometimes it's fun to do things live. You see me make mistakes, and we learn from mistakes. And so you realize this is actually very slow. It's done. Now it's picked out 104 countries instead of 251 that we had earlier. And true enough, Singapore is the last entry here. And guess what's the first entry? Hong Kong. Okay, so it's picked out Hong Kong to Singapore and everything in between. Okay, so that's how you do StartAt and EndAt. And then there's also things like LimitToFirst, LimitToLast. What is LimitToFirst, LimitToLast? That is just basically saying after you sort it, give me the first 10, or after you sort it, give me the last 10. And you would think, how would I use this? An example would be leaderboard, right? If you had 1,000 entries in your leaderboard with scores and you just want the top 10 players, you would limit to the last 10 because that will be your highest scores, right? Remember, it's sorting from the smallest to the biggest. You pick the highest, so you limit to the last 10. So as an example, let's do this. Let's limit to first. To firsts. Okay, limit to last 10. Okay. I'll just limit to last 10. And let's see what we get. So I've sorted the countries by its alpha 2 code, and I'm picking the last 10 out. Okay, finish loading 10 countries. And true enough, I only had the countries in the last few alphabets of the alphabet. Sorry, Z, what? Y, oh, this I'm alpha 2 code, right? Y, X, W, V. Okay, so with the last 10, and you can do the same for the first 10. Now, the thing about these filtering things, we can chain them. So let me just say limit to first 10, all right? But I can say start at, let's just say I want to start at Singapore. So if I start at SG and I limit to first 10, let's see what happens. Okay, so I start at SG and then I pick the first 10 after SG. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it. I load 10 countries that started at SG. So this is how you use the filtering. Okay, and of course, if I only wanted one thing, sorry, I'm trying to get back here, right? I can also use EqualTo. Okay, and maybe before I get there, these two limit to filters, they work on count, meaning that I want to limit to the first 10 records or the last 10 records or whatever. That's the count, okay? The count of the number of records. Now, these filters work on the value. So start at, start after, and at, and before, these the values. So for example, these are values. Hong Kong, Singapore, these are values. Now start at is an inclusive filter. Start after is an exclusive filter. I hope that English is something that you can understand. It's pretty straightforward, right? So if I start after Hong Kong, then you will not see Hong Kong. You will see the entry after Hong Kong, okay? And before, then you will not see Singapore. You will see the entry before Singapore as the last entry, okay? So start at, EndAt, start after, and before. And the last one is just equal to. So if I wanted to pull that one record, or in fact, maybe inside your list, there are multiple countries with the same, I don't know, something, right? Let's say, I don't know. Let's say I want to pull countries with the same time zone. Right now I can't because this is kind of complex, like array. But if I wanted to do that, I could, right? Or if I try to find out like which country actually share the same DAO code, okay? So for example, if I wanted to find out which country shared the same DAO code, I could do it. So let's try it. There's definitely countries sharing the same DAO code. That's the interesting part about this. So let's just say, okay, equals to, and I'm going to change it to DAO code. Remember that we need to use the sort to get the key. Okay, and I only want countries that have DAO code 1. Okay, and so if I wanted to pull that exact DAO code, that's what we do. That's what we get. Okay, let's run it. While it runs, I'm gonna get a drink. And this is me with asynchronous operation. I'm asynchronously drinking. And this is also a very good example for the reason why we use asynchronous code, because you can see this starts getting slower. Okay, it takes 5 seconds or so to get the list. And there we have it. We have 2 countries sharing the same DAO code. It's actually USA and Canada. Okay, so we have talked about filter. Now, we realize that some of this takes a while. And there is a reason. Now, why is it that it takes a while? Because the database has to go through every entry and look for that value and try to match it. And that's what the database is doing, right? If you say sort by alpha 2 country code, what it does is it's looking at alpha 2 country code and it's like, oh yeah, let me sort this. And then like, where should I put this? Where should I put this, right? It's sorting it as it looks at the values. Now, if you imagine yourself having to look through a bunch of files, like, I don't know, you guys have seen going to the doctors in the old days, right? You go to the doctor and say, what's your name? Or what's your IC number? And you just say your IC number and they go to the file like, oh, A, your name starts with A, your name is Alex. Let me pull out card, Alex. Okay, here you are. That A that they pull out, that's an index, right? It helps them find that card, Alex, a little bit faster. And so databases have the same concept. They have something called an index. An index, of course, in the simplistic example I gave is what we can understand. But in a database, an index is actually a data structure. And they come out with different data structures that they use. The most common one is called a B tree or balance tree. So it's a data structure that the database adds to help find things faster. But you can't just say, like for example, like the doctor, right? He's indexed his filing cabinet by alphabets of the name. And if you decide one day, like, hey, instead of name, I'm going to give you my phone number, the doctor is not going to be able to pull out your card because he needs a different index to pull phone number, right? He needs to now take all the cards out and now sort them by, from 0 to 9 for the first, second digit of your phone number to try to pick out a phone number of a patient by phone number. So same thing for a database. You kind of have to tell it what to index, right? And of course, you can try to index everything. I can say, hey, database, can you index the name and the country and this and this and this and this? Database can do it. It's not going to be efficient. Why? Because imagine the doctor has to do the same thing. I have now to index by name and index by phone number. And if you were a doctor, what would you do? The patient filled out a card with his particulars, and you're not going to put it in the cabinet with, that says A for Alex, A. And now, phone number, 8440, and I'm going to put second digit is 4. I need to put it in the cabinet that says 4. The doctor would have to take this card, make a copy of it, and stick it in 2 different cabinets, right? So if the patient came and said, phone number is 8440, blah, 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 I will pick the card from the phone number cabinet. If I said my name is Alex, I'll pick the card from the name cabinet. And that's exactly what happens in the database. If you tell the database, now go index everything here, the database would then have to create an index. Of course, it doesn't have to copy every value. What the database does is say, okay, I have a record here, okay, a city called Dundee in Oregon, United States. And I will then create an index, right, that says, okay, if country is in US, go and pick this record from, this place, right? This particular filing cabinet has this record. And if if the name is Dundee, starts with the D, go to that filing cabinet, find the D, and then go pick it up from this cabinet. So they have the data stored in one place, and then the index references that data. It tells them where it is. But there's still an impact to the database. What's the impact? It makes it slower when you write the record. So if I'm like adding more and more countries all the time or cities all the time to my database, this write impacts the performance of the database. Now the data, every time you write, it has to go like, okay, you're writing this record, let me index the name, let me index the country. And if you add more indexes, you're gonna start indexing more things. It makes the write slower, okay? So that's a performance impact when you index something, okay? So this is why we don't index everything. Now, how do you index something in a database? This is interesting. And I haven't rehearsed this before this lesson. So I'm just gonna do something. Let's go to cities, right? And I wanna pull out Singapore from the city. And we all know that there's only one city in Singapore, right? How do I do it? Now, I'm just gonna turn this like to load countries. Let me just like get rid of this void start. Let's make another start here. And okay. And I'm gonna say, I'm just gonna copy some of these things here just to reduce my typing. Okay. Loading city. Okay. And now cities, and I will order by child cities. Okay. Let's see. I will order by child country. Okay. And I want the country Singapore. And I would say city retrieve task, and I have my cities retrieve task here. Okay, all done, all great. And I'm just gonna copy paste this bunch of code as well, so I don't have to rewrite all of them. So I have my database. I'm now reading the cities list, and I'm gonna find the cities with a key country equals to SG. Okay, and I'm just gonna pull out Singapore, one record. Okay, cities. Okay, cities, and instead of doing this deserialization, because I don't have a city object, I'm just gonna print the JSON. So let's go data.get raw JSON value. Okay, I'm just gonna print the JSON value, and let's see what happens. So let me just run through this quickly again. I'm just getting a bunch of cities. I want to match the country key here. I'm getting a bunch of cities, okay? And I'm just going to match the country to SG. And hopefully I pull one city out, and that city is Singapore, okay? And here's just the regular get code, right? The retrieval code. Error checking, check if the data exists. If it doesn't exist, vomit an error. Otherwise, count the number of entries I have. And for every entry I get, I'm gonna just print it out, and I'm gonna be done. Okay, so that's it. Let's run this, and you'll be surprised what happens. I haven't tested it, but I'm pretty sure. Here we go. Well, let's see. I think while we are waiting, we can all take a break. I can go get some food. You can order a waffle from Creamy Duck. You come back to this demo. Basically, 3 hours later, you will not see anything. The reason why is because, I'm just gonna stop this and stop wasting resources. The reason why you will not see anything is because there's 177,000 rows in the city data. Okay, so here, scroll all the way down, There are 177,737 records in cities, and it's going to take forever to sort the countries, then pull out Singapore. So the way to make it faster is to add an index. And how do you do that? I can't remember, because this is a Firebase thing, you need to read the documentation. How to add index to Firebase Realtime Database. Here you go. And here's how it works. Rules. Dinosaurs. I'm just going to copy this. So rules are already there. Okay. And it's going to copy the bunch of stuff here. Rules are already there. Okay. So I'm going to paste dinosaurs. And of course, I don't have dinosaurs. I only have cities. And I'm going to index on a few things. So I'm just going to look at my city data. Okay. City data has country. I want to index country. And maybe I want to index population because I'm going to sort by population in a bit. So I'm going to say country and pop. Okay, I'm going to filter by pop in a bit. Okay, maybe I want all countries that's more than like all cities that have more than 5,000 people as an example. Now, once I've done this index, I don't know how long it takes for Firebase to actually reindex my data, so it has to do that in the background. Okay, when I do this, it has to go do the reindex, and then I can run my code on it again. Let's try it. Ooh, you know what happened? Unity has crashed. Basically, that previous asynchronous task is still running when I stopped. This is what happens in the editor. So you're gonna force quit this thing. I have to reopen it. Okay. So I hope I didn't blow up my Firebase usage, because if you exceed your Firebase usage, then you will have to click this upgrade button and pay money, which is not good. Anyway, back to Unity. Okay, I'm just going to turn my canvas off again. Forgot to save my scene. That's the thing you want to do. Hit save every time you do something. Okay, run. Now, there you go. Hey, we have retrieved all the cities in Singapore. And for some reason, this data that I have actually listed Changi Village. What's a Matilda Estate? Don't even know that exists. Novena, Marine Parade, UT, Orchard, Keat Hong Village, Tanjong Pagar, Chot. What is Chia King? Eunos, McPherson, Yio Chu Kang, Bedok, Ulu Bedok. What's Ulu Bedok? Teck Whye, Jurong Town, Jurong West. Hey, there's two Jurongs. Woodlands, Anak Bukit, Sengkang Newtown, Marsiling, Sungai Simpang, Boon Lay, Punggol, Choa Chu Kang, blah, 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 blah. There's some interesting things that I've never seen before. I don't know where this data came from, by the way, but this is interesting. And here, we actually know like there's a population, like Bukit Timah has 77,000 people? Really? Okay. And there are 46 cities in Singapore. Now, for the fun of it, I'm just going to stop this. Say I wanted to, let's do some practice here, okay? I wanted to sort the database data by the population, right? I could say OrderByChild, pop, okay? That's population, pop, okay? And it should sort by the smallest population to the largest after it filters Singapore. I hope this is correct. Once again, let's try it. Let's run it. Oh, no data found for cities. So I goofed up somewhere. You can't just sort by pop this way. Now you could say sort by pop, then by country, then equal to. I don't know if this works. Let's try. These are quirks of Firebase. I have no idea if it works. There you go. Now I've sorted by population, and definitely there's some wonkiness here because population is a string, and so nope, it's not sorting. So I'm not able to sort by population, then filter the country. I'm gonna leave this to you to figure out how to do compound sorting in the database. But let's for fun now order by population, and let's find the biggest populated city in the world. How do you do it? I sort by population. It's just like your leaderboard, right? And I want to get the last few entries. So I'll say last, limit to last, limit to last. Okay, let's just say get the last 20 cities in the world with the largest population. Let's try it. There you go. Oh, guys, you know what's wrong? Once again, population is a string, not a numeric value. So instead of sorting by a number, a large number, it's actually sorting it by sort of alphabetical order, right? 9 comes after 8. So all the population that starts with 9 is showing up here. So including this, you see this, right? This is 9995, 9950, and 9996, 9996. So this is bad. So if you really wanted to sort by population, you had to make sure that population is a number. And unfortunately, this is a fail demo. And it's a good demo because it tells you to make sure your data type is correct. Okay, so I've talked too much. Oh, I forgot about indexing. There's the last bit. There is a keys are automatic. Yeah, I need to mention this. Okay, keys are automatically indexed. So all keys, these keys here are indexed. You don't have to index the key to sort them. So order by key always works very well. Okay, values need to be specifically indexed. So what we just did was index the value, right? Index on by key or child or value. So if you want to use order by value, this is what the documentation is for. And this is like the leaderboard thing that I was saying. And you wanted to index the values like this, you got to use this to index. So you want to use scores, which is this is the key scores, and put index on its value. Okay. So if you have a structure like this, you got to create the index this way. So that's all I have to cover for indexes. And yeah, feel free to ask me questions. Bye.